All right, so as we conclude 1.3 here today, this is the fourth video for 1.3, and we're talking about surface area of three-dimensional objects. We started with two-dimensional objects like a circle and a square, rectangle, triangle. I believe we even did trapezoid, right? A trapezoid. So we know how to find the area of lots of two-dimensional shapes. Then we moved to three-dimensional figures, right? And we learned how to find the surface area, like the total surface area of three-dimensional figures like this, right here. And we have to consider all the sides, of course. And we have to work it out from these diagrams how we might determine what the side lengths they are. And we drew net diagrams, right? So today, what we're going to talk about is, I got to find my notes again here now. Today, what we're going to talk about is these guys right here, cylinders. Okay, we haven't talked about cylinders yet. So let me just see if I can find here we go. So surface area of cylinders. Now, cylinders in real life, candles, pipes, cylindrical, gas tanks like this, something that is circular and has height. Okay, so the ends of a cylinder are circles. So here's a couple diagrams that you might be familiar with. A cylinder has a circle for a base, okay, and it is extended upwards with an identical circle on the top. We're only going to be dealing with like right, where the base or the top and the sides form a 90-degree angle. So it's like right circular prisms, if you want to call it like that. So cylinders, right cylinders. There's also, actually, I saw, oh yeah, right here, look at this. So a right cylinder has a 90-degree angle formed by the top and the bottom along with the side edge. You see that, 90 degrees. This is called an oblique cylinder if it's tipped over and the angles between the base and the side are not 90 degrees at all. That's an oblique cylinder, okay? So we're only going to talk about right cylinders here today. Yeah, as we go back. So the surface area, what I want to do is I want to highlight a couple things. The radius is going to be really important for the cylinder, and that is the distance, as you know, in a circle, the distance between the middle and the outside edge, okay? So from the middle to the outside edge is the radius. That's going to be very important. Also, the overall height of the cylinder. So R and H, super important for calculating surface area. We're going to get to this problem in a second, but what I want to do is I want to show you what the net diagram looks like for a cylinder. Now, you may already be familiar with this, but I'm going to put this just up here, actually. So, where's my pen? If you're drawing a net diagram, which I'm going to get you to do for your problems here, what you want to do is you want to focus on the top and the bottom, and then the wraparound part. The top and the bottom, pretty easy. They're just circles, right? So you just draw your best circle for the top and your best circle for the bottom, and it doesn't matter where they are, if they line up right over top of each other or not. But the wraparound part is the tricky one, okay? What shape is the wraparound part of a cylinder? If you were to slice it, if we were to slice it right here with a knife, okay, at a 90-degree angle, and we were to unwrap it, what would that shape of the wraparound look like? A rectangle, okay. So do you guys see that's correct, by the way? Do you guys see that if we cut this and opened it up, it would start to kind of unwrap here, all right? It would unwrap, and we would have, this would open up, and it would form a rectangle. It's not a trapezoid, it's not a triangle or anything like that, but it would form a rectangle. It would look something like this. So this is the net diagram for a cylinder, a net diagram for a cylinder. You got the top and the bottom connected to a rectangle which represents the wraparound side. So the radius obviously is still right here. That's R. This is H right here. Okay, that's H right there. And the other important thing that we need to know is what is this length right here, okay? Because we know what this dimension of the rectangle is, we know what the radius is, but we need to know this side too. Oh, thank you. Okay, thanks. All right, so any ideas? Any ideas on what the length of that rectangle might be and what it maybe is associated with in this cylinder. Okay. Yeah, go ahead.
Is it a diameter, like the diameter of the circle?
Is it the diameter? Okay, good guess. The diameter, remember, is twice the radius. Now, this isn't necessarily drawn to scale, but it isn't quite the diameter. It's a little bit more than that. Okay, so it's a good guess, though. That's a very good guess. Now, what I like that you noticed was that this length right here is somehow, represented. It was a wraparound of this. So think about that. So what is the wraparound of this circle? I had a hand up at the corner. Yeah.
Circumference.
Okay, very good. The length of this rectangle, that is the wraparound part, is equal to the circumference. Remember, we cut the circle. We cut the circle right here, and then we folded it down. So this side, went down to there, and this side went down to over there. And so, yeah, it's the circumference of the circle just flattened right out. So what is the formula for circumference? It's a big capital C. Anybody remember what the formula for finding, and that's the circumference is like the perimeter around the circle, right? You guys remember what that formula is?
Is it pi times diameter?
Is it pi times diameter? Okay, who remembers? Okay, I see some heads nodding. Okay, there's two ways to write that. You're exactly right. That's one of the ways you could write that. So pi times d is the circumference, also equal to 2 pi times r, because the diameter is 2r. So I would encourage you to remember this one, because a lot of times the radius is involved in so much stuff in circles. So you want to remember it in terms of r, but both of these are correct. That's right. So the circumference of any circle is 2 times pi times r, or pi times the diameter. So you're close with the diameter, just have to multiply it by the special constant of a circle, which is pi. All right. Oh, whoops, I erased the wrong thing. Okay, so what this means is that we can find the area of these two circles, right? The area is pi r squared, okay? And it's very important that you don't confuse these two. 2 pi r and pi r squared, they have the exact same numbers and symbols. They're just in a different order. So you have to remember that the squared is area, okay? There's no squared here, so this is not an area. This is just a length. It's a perimeter. It's the distance, okay? If it has a squared, it's the area. That's how you can remember the difference between these two, okay? So 2 pi r and pi r squared, different. The squared is the area of the circle. Okay, so here's a equals pi r squared on the top as well. Now, an area of a rectangle is always length times width. And the width is the height here in this diagram, and the length we said was 2 pi r. So the surface area for a cylinder, I'm actually just going to get rid of this for now. I'll bring it back later. So this is very important. I want everyone to write this down in your notes here. The surface area is two circles that are identical, the top and the bottom. So that's 2 pi r squareds. Right? Pi r squared is the area of a circle, so we need two of them, plus 2 pi r, that's the length, times the width is h. Okay? So you got pi r squared in the top, pi r squared in the bottom, and then a rectangle of length 2 pi r and of width of the height. Okay? Very important. Make sure you have that written down, okay? Okay, so for this example, this is the one you wrote down earlier. The surface area is not to be confused with the volume, which we haven't really talked about yet. But the surface area is the exposed area of all of the surfaces, right? That's the surface area. So we need to consider the top, the bottom, and the wraparound part. So surface area for this particular cylinder. What is the R? We should probably note that. What is R? Is it 10? No, R is 4. Very good. It's 4. And now this is meters and this is meters, so they're the same units. That's perfect. We have to have them the same units. If they're different units, you need to convert. If one was centimeters, let's say, and one was meters, you'd have to make sure they're both in the same units. And what is the height then? The height is 10. Very good. So the surface area is going to be, and again, when you do these questions, I'll require you to do this step. Please do not just do everything on your calculator and give me an answer. you should write down the formula at least one time on your page so you can see that, and I can see that you know what you're doing. But for each question, plug in your values, and when I say plug in, I mean insert the values into the appropriate spots in the expression, and then evaluate. So show me exactly what I'm doing here. This is the model for you, okay? So 2 times pi. Now the r we're going to fill in. That's 4 squared. And you can put the squared inside the brackets too. That's okay. So what I mean is you can write it like this as well if that makes things a little more clear for you. It doesn't really matter which way you do that. Plus 2 pi, well, r is 4 again, times h, which is 10. So I'll need to see that line of work, all right? After that, if you plug this all into your calculator and get an answer from here, I'm totally fine with that. But I need to see that you're using the right numbers and you're understanding the formula. And please begin to memorize this formula. That would be perfect. Don't rely on looking at your book all the time, but memorize the formula. Okay, so we get the calculator out. And again, we're going to try and use our pi button with our scientific calculator. If you don't have a scientific calculator and you're working on this, the value for pi that you can use, remember, is 3.14159. Please go to that 5 decimal places if you don't have the pi button. Then you'll get a precise answer. But if you have a calculator, you can just use the pi button. So let's try and do this all in one shot here. 2, okay. Now you can, for most of your calculators, you can hit times, or you can just write pi right next to it, and that means 2 times pi. Okay, so 2 pi, all right, and then you can just use your brackets, 4 squared, plus 2 pi. Now, if you want to do this in your head and write down times 40 right there, you can do times 40, or just write brackets 40. Let's see what happens there. So doing it this way, my calculator gives me 351.86. Is that what anybody else gets? Yeah, you guys got that? Okay. Let's try it a little different way. Let's do 2 times pi times, and if you could do this in your head, that would be great, 16 plus 2 times pi times 40. Let's see. Yeah, same answer. So please make sure that you know how to use your calculator. That's why you need to bring your calculator. You need to know how to use your calculator. Use the brackets appropriately. If you just type in all the operations in a row, it may or may not do the proper order of operations. So you might need to help it, but with some brackets. Okay, this is pretty simple. It's just multiplication and addition, so it should be able to straighten that out. But please make sure you get this number. So 351, we'll always round to 2 decimal places if we don't really know where we should round to. Round to 2 decimal places. That's a pretty precise answer. 351.86. So the surface area is 351.86. Now my units are going to be what? Meters? Squared, thank you. Meters squared. Please do not forget the squared. Remember, this is 4 meters, and we've squared it, right? This is 4 meters times meters. That's a square meters right there. So we're adding meters squared plus meters squared. We get meters squared. All right. Okay. What I want you to do, because some of you guys look pretty confident in this, here's another example. I want you to draw a net. Draw a net diagram. Label it, and calculate surface area. Calculate surface area. All right. So here's the cylinder, and in order to draw cylinders, can I just help you out how to draw a cylinder? Draw an oval. So an oval is like a flattened circle. Draw an oval. Don't draw like a perfect circle. Squish it. Because again, we're drawing a 3D figure. And then what I would do is I would draw 2 identical lines from each side that are about the same length. And then instead of drawing another oval to make this like a solid figure, just draw a curved line that's the same curve as the top, as this bottom edge of the top there. So you just kind of draw something like this. Doesn't have to be perfect, but you have a curved line at the bottom and an oval on top connected by 2 lines. So that's a good way to draw a cylinder. And if you want to be really fancy and say, oh, here's the back side of the bottom of the base, and you would draw that with a dotted line because it's an edge that you can't really see from the front, but you know it's back there. So that's where dotted lines come in. So if I was to draw a box, watch this. If I was to draw a box with an open top, I would draw something like this, and then the inside of the box, I would draw a solid line here if it has an open top, and then dotted line here to show that that can't be seen from the front. You see that? So I do that in calculus all the time. Draw boxes like that. And that diagram right there says that there's an open top because I can see inside the box with the solid lines, and the dotted lines I can't see. So I can see this top edge, I can see this top edge, I can see this bottom edge, but I can't see the back edge, therefore it's a dotted line, okay? All right, so here we go. I'm gonna give you a diameter. D is 14.7. And I'm gonna give you a height of 3.5. Nah, that's not to scale. Let's go 13.5. How about that? Then that looks a little bit more to scale there. Okay. So take a couple minutes, draw a net diagram of this shape, label it, and then calculate your surface area showing all the work like I showed you. Okay? Go ahead and get started on that. All right. Here is the answer that I got. Does that match up with anybody else's answer? 962.88 units squared for a surface area here. All right, so let's go through this. And I saw something interesting when I was walking around, so I would like to talk about that too. So what we want to do is we want to go with the surface area formula, right here, the surface area formula that you all are going to memorize here. 2 pi r squared plus 2 pi r h. And we want to plug in our values just like we did here. 2 pi r is half of the diameter. So half the diameter is 7.35 in this question. Plus 2 pi times r, 7.35 times 13.5. So if you plug that into your calculator, you should get 962.88. Now I will mention something that I saw here, which is I'm actually really glad that I saw it because it gives me an opportunity to talk about it. When we were talking before about diameter versus radius, something interesting. So 2 pi r h, you can use the diameter here, and this can be pi times d times h. That's okay. But what I saw on this part here, okay, was one student did this, 2 pi r squared, and they put pi times d squared, okay? Now on the surface, that might look pretty smart to do, okay, a good idea. You've got 2r there, why not just do the d? The problem is this, is that it's only the r that's squared, it's not the 2 that's squared. So by writing this as a diameter here, this is what you've actually done. You've actually done pi times 2r squared, which is the same as 4 pi r squared, because the 2 gets squared as well. So you can see that 2 pi r squared actually doesn't equal 4 pi r squared. So that's why you can't do this one. This one's no good, okay? So I don't know if anybody, I only saw one person try that, which is, again, this is where we learn. So I would encourage you to kind of stay away from using diameter, honestly. Stay away from using diameter in your calculations. We don't really use diameter after grade 9 so much in these calculations. It's always r. Everything's r. If we have a diameter, we convert it to r. As you move through, you know, if you go into calculus, okay, into pre-calculus and calculus, all right, the d is just a trap. We always convert to r because all the formulas are in r. The formula, you know, for the area of a circle, for the area of a sphere, the volumes are all radius and all that sort of stuff. So let's do r instead of d whenever we can, okay? But I'm glad I saw that because there's a good opportunity for me to explain that. Okay, all right, so you guys are pretty confident about cylinders now? 2 pi r h is the wraparound part, and it looks like a rectangle, okay? It looks like a rectangle. So once again, this surface area formula, super important. Make sure you have that written down, and make sure you know how to use that. I'm gonna skip over to another page here. Now I think you guys have a page that has cylinders on it, don't you? You have a worksheet. Like, do you have this one? Surface area of prisms and cylinders. Do you have this one? Is that in the one with the nets here? Okay. So you should have this handout here with the net diagrams on the front, and the second page, I think, is this one right here. Yeah, that's the second page there. So if you've done some of these, that's great. I taught you how to do the triangular prism yesterday. So let's skip down here to number 6, which is a cylinder. And let's do the cylinder one together just so we're clear on that, okay? Does anyone not have that sheet? Were you not here yesterday or last day? Yes, hurry up. Go quicker. You bet. Okay, surface area for a cylinder is 2 pi r squareds. That's the circle on top and the circle that would be on the bottom. Here's the back edge of the circle we can't see. There's 2 circles there. Plus 2 pi r, that's the circumference of the circle, which is the length of the rectangle of the wraparound part, times the height, which is right here. Okay? So 2 pi r squared plus 2 pi r h. Now, if this is a building or an oil tanker container or something that's sitting on the ground, and you're asked to what's the surface area of the tanker or of, you don't have to count the bottom lots of times. If we're painting something, don't count the bottom, right? So it's just 1 pi r squared. But if it's a figure that's just hanging in space like this, we'll go 2 pi r squareds. Okay? All right, so we fill in the values here. So surface area is going to look like this. 2 times pi times, what's the radius here? It's 10, yeah. So 10 squared. And again, where you put the squared, inside or outside the brackets, doesn't matter. Just please do not square the whole thing. You cannot square this whole thing. You just don't do that. It's 2 times pi, and then times just 10 squared, okay? Plus 2 times pi times, the radius again was 10, and the height is given as 16. So again, the second part is the wraparound area of the wraparound side that we would see. And this part right here is the area of the top circle and the bottom circle. All right, so we'll put that into our calculator. So, well, I guess I gotta go on. 2 pi. 10 squares is 100, so I'm just gonna go, bracket 100 plus 2 times pi times 10 times 16. So 2 times pi times 100 plus 2 times pi times 10 times 16. So 1,633, so 1633.63. Whoops. 1633.63. And that's going to be square yards or yards squared. All right. So once again, you need to show this step for sure. I would encourage you to write down the formula for the surface area for a cylinder somewhere on that page, but make sure you have this and you have your answer 2 decimal places. Excellent. Your units are proper there, yards with a squared, and you've got your answer circled or identified there. Okay, any questions about that one? Okay, why don't you do number 8 then on your own, and we'll see how you do with number 8, okay? So do number 8 on your handout on your own, give that one a try, and I'll reveal some of my work in a minute here for you. This is what I got here. 791.68 inches squared. Anybody else get that? A couple of you did? Got many of you did? All right, awesome. Okay, hey, that's great. So I want you to go ahead and finish the rest of your worksheets that you're given. Also, let's see, this one here, I just want to highlight this. Before you get too far, I'll just throw this on there because we haven't talked about this one yet. This is a little bit of practice with the nets, Okay, so we haven't had a lot of practice with net diagrams, but what it says is count the unit squares and find out the surface area of the shape represented by each net. So each square is 1 foot squared. Now, this is a net of, I don't know if you can even see that, it's hard to see, but this is a net of a rectangular prism. It's like a box there. Can you see it? It's better on your paper there. But what you want to do is you want to count the number of squares. Now, it's going to get a little bit tedious to count all the squares. So what you can do is I will allow you obviously to use the multiplication for each area, and then you can always, then I want you to double check by counting at least. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So I got 21 squares there. Now it looks like this is 7 by 3. All of these are also 21. You see that? 21, 21, 21. They're all the same size. This one is 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9. And this looks to be 3 by 3. So 3 times 3 is 9 as well. So the surface area would be all of these added up. 42, 84, and 18 is 90, 102. Okay? So 102 feet squared, because each block would be a foot. And if you were to count them all up one at a time, you should get to 102. All right? So aren't you glad that we have equations and expressions for area? We don't have to draw everything on a grid paper to scale and then count all the squares. Aren't you glad that we get to multiply? Yeah, question?
Wait, how's that even like a box? Because there's like four short sides.
How is it a box? This is a net for a box. Yeah. So it's not, so it's a little bit hard to see. Let me just outline this for you again.
21 is the second one.
Yeah, like
That's the base, and then those are 2 sides, and the furthest one to this side is the top. That's the one.
Yeah. So look at this one. This one could be the base, right? And then you have 2 sides here. One side. They fold up. And then this one that just went away on me. Okay, so bottom, side, top, and then end and end. So it's a box with kind of a square end, and it's long like that. Okay, there's that back edge right here, and a back edge over here. Does that help? Answer your question? All right, so the other one I'll point out to you guys here is this one. This is a triangular prism down here at number 6, right? So counting the squares here, these are half squares right here. That's a half, that's a half, that's a half. Okay, so there's a bunch of half squares here. So you count the full squares and then half squares. So 1, 2, 3, 4, 5, 6 full squares, and then 6 half squares. So that's going to be 6 plus 3. So this should be 9 units. And let's just check with the formula there. So 1/2 the base. What's the base? 1, 2, 3, 4, 5, 6. The base is 6. The height is 1, 2, 3. So the height is 3 here. So the area should be 1/2 the base times the height, which is 1/2 of 6 is 3 times 3 is 9. Look at that, it works. So your formulas should match up with what you draw.
Where'd you get the 1 over 2?
That's the area for a triangle. You can also write like this, b times h over 2. So those would be the same area, right? You can do 1/2 in front, or you can do all over 2. Okay? All right. Okay, so you're gonna want to finish those worksheets, and I'll give you some give you assignment from the textbook as well today and tomorrow to finish all your worksheets and to do all of your textbook questions for 1.3. Okay, any questions before we leave here? All right, so cylinders is the main thing for today.